keluar. Hi, Assalamualaikum and a very good evening everyone. We are from Group 8, Complex Analysis. Today we are going to present harmonic functions in robotics and hydrodynamics. Before that, I'm going to introduce my group members. Myself, my name is Nur Izzah Afiqah binti Muhammad Zamri and my metric number is 199103 and my group members is Nurul Fatin Atika binti Muhammad Rashidi 199036, Nurul Arni Akma binti Muhammad Zaini 198969, Nur Afika binti Abu Safian 199077, and Siti Zulaika binti Zakaria 199116. I will pass to my mates Fatin for introduction.
Okay, thank you, Afika. Thank you, Izzah. So today I'll proceed with the introduction about harmonic function. So to the next slide, Izzah. Okay, thank you. By defining the definition, harmonic function is defined when the function of z, which is uxy plus ivxy, in which uxy is the real part and ivxy is the imaginary part. This function is analytic in domain D. So when this function is analytic in domain D, uxy and vxy are also harmonic in domain D. So for it to be harmonic function, we need to satisfy this condition in which the second degree of partial differential equation in which u, xy, we partially differentiate it twice with respect to x and with respect to y. So when we add it together, it needs to equals to 0. And the same, that is the option 1. So for the second option, we could also partially differentiate twice the function of vxy with respect to x and with respect to y, and it needs to equals to 0 too. Okay, so that is the basic information about harmonic functions. So moving on, there are numerous applications of harmonic functions in our daily life. So Izzah, the next slide. So the first application of harmonic function is in unified interpolation frameworks on graphs. So a paper by Ghonim, El-Muataz and Lazare in 2011, their paper mentioned about how discrete infinity harmonic function they works towards in unified interpolation framework on graphs. So for your information, many image processing and computer vision are formulated as interpolation problems using several partial differentiation equation techniques. So in this case is harmonic functions because harmonic functions need to satisfy the partial differential equation. So for example, there are three applications in the frameworks, and the first one is image and video colorization in painting, and third one is the semi-supervised segmentation. So if we look at the picture, there are these are the application in painting, and from the figure A, you could see that the picture is corrupted, and when you apply the infinity discrete harmonic function, the corrupted image can be fixed and they are more clearer. Okay, so to the next slide. So in this presentation, we will focus on two applications which are in robotics and hydrodynamics. So I would explain about the robotic application first. So we found a paper by Christopher Connolly and Roderick Gruppen where they mention how the application of harmonic functions in the robotics. So here it is said that the harmonic functions, they are proven to have a number of properties that are essential to robotics application. So they prove that harmonic function can be used as the basic to a reactive admittance control that allow incremental updating of the environment model, which responds well to sense changes in the environment. So the second one is a paper by Hans Bowie. They mentioned about how harmonic function can be applied in hydrodynamical. So this is actually a field of study focusing in the physics. Um, in this paper, they figure out how harmonic function on the hydrodynamics application that are used to design pipelines, pumps, and also spillway dams. So I think that will be all from my part, and then I pass to my team members, Afika and Zulaika, to proceed with methodology. Thank you.
Okay, for the first methodology, it will be the application of harmonic function in robotics. So for the first methodology is how harmonic function can be applied to robotics. To be more specific, harmonic function can be applied in robot path planning. This because according to Gauss integral theorem, it satisfies the integral where the integration of the function over the n dimension is equal to 0. Therefore, it satisfies the theorem where it states that there is always an exit from a region. This applies in robotics where there will be a starting configuration, which will be the start point of a robot, and goal configuration, which will be the destination of the robots. And then it also satisfies minimum and maximum principle, where the effector will always reach its goal. So next slide. Okay, so in order to apply harmonic function in robot path planning, first it must satisfy Laplace equation on domain omega in R power n. So this is true since we know that for a function to be harmonic, it need to satisfy Laplace equation through the formula given. So to compute this formula, xi will be the Cartesian coordinate and n is the dimension. Then the boundary of the boundary of omega denoted as delta omega are held at obstacle potential where the harmonic function is equal to 1. So this actually refers to the boundaries of all obstacles and goals in robot path planning. After that, all goals region are held at goal potential where our harmonic function will be equal to 0. Then for the streamline, which is disturbance of the path, is computed using gradient of harmonic function, which will be act as a velocity or displacement for the effector. So by using this formula, which current state in configuration space equal to velocity gain times with streamline. So through this step, a simple streamline for robot path can be obtained, and this step can be applied for a simple robot path planning. Okay, so I will pass to Afika.
So next, we move on to the application of harmonic function to hydrodynamic. As you can see, I took one of the theorem from the paper at the reference, where let function u be harmonic near the origin in y less than 0, and function v a conjugate harmonic of u. Assume that u v partial u with respect to x exists and are continuous in the semi neighborhood y less than equal to 0 of the origin. If the boundary values on y equals to 0, it will satisfy a relation where partial u with respect to y is equal to a function a that consists with variable x, variable u, variable v, and partial u respect to x, in which a is an analytic function of all four arguments for all values occurring. Then function u and function v are analytically extensible across y equals to 0. So as you can see, this theorem we can use to apply the harmonic function into the hydrodynamic application. So next slide. So, like I said before, this theorem can be applied to the irrotational steady flow of a homogeneous incompressible liquid in the neighborhood of a free boundary where the pressure is constant. Uh, Actually, this is one of the application physics. In physics, like Fatin Atika have explained in the introduction before, and then this theorem can be derived more that will satisfy Bernoulli's law that holds T plus V equals to constant, where T is the kinetic energy per unit mass and V is the potential energy of gravity per unit mass. So next. So by the previous equation, we can do more. We can do a further proving, and it will show that that equation is a harmonic function of gamma and of the variable. Hence, this theorem is applicable where function y is an analytic function for each harmonic function for gamma equals to 0. So it is also similar to its conjugate uh, and we can use the same theorem to prove that its conjugate is also analytic. And then if both are analytic, so the assumption has been made that the velocities of particles are continuous functions on the point on and near the free surface. So next I'll pass to Nurul Arni and Iza for the results.
Okay, thank you, Afika. So I'm going to present the result for harmonic function of robotics, where admission controllers derived from equipotential surfaces can develop for use with harmonic function path planning. We can see the equation where there is include the velocity times streamline, and the Q is the current state in configuration space for a revolute robot manipulator, and W is the contact force observation for a revolute arm. The first term, this term, is a normalized gradient descent on the potential harmonic, and the second term is an admittance relation designed to respond to forces derived from contacts with unmodeled C-space barriers. The harmonic function provides the basis for a hybrid control that can be structured along the streamline, and force can be regulated in the orthogonal equipotential manifold. And the harmonic function also prevents difficulty in path towards the target smoothly, even though the iterates are not harmonic. Okay, so we look to the figures where this figure shows the effect of combining the equipotential admittance controller with continuous harmonic function computation. The lower channel is completely blocked with unsensed obstacles, okay? So we can see to the figure, when this system, it injects into the harmonic function environment because there are the obstacles. Then the harmonic function updating tends to lead the system toward the goal when admittance control is used to escape to other streamlines, and new barriers deform the harmonic navigation function continuously towards a solution that circumvents these limits. Okay, next, I will pass to Arnie.
Okay, for the next result, I will proceed with the application on the hydrodynamic. So as the result toward the application on the hydrodynamic, the Bernoulli relation, which is B prime, is no longer solvable at P with respect to partial Y, respect to partial gamma, is in analytic manner, and our theorem no longer applies if this happen and at an isolated point P. Since that t is more than 0, they are derived from Bernoulli law, which is this one is a physical application, a bound for the elevation of the free surface, which bound is obtained by setting formally t is equal to 0. Okay, so if the assumption that t is more than 0 is dropped, the possibility that y is equal to 0 or t is equal to 0 uh, will arise. So I will proceed with the final part, which is the conclusion. Okay, next slide. Okay, to sum up, harmonic functions appear regularly and play a fundamental role in maths, physics, and engineering. Function of z equal to u as y plus iv as y is called a harmonic if it is continuously differentiable, means that if the derivative f prime x exists and is itself a continuous function and satisfies the partial differential equation. So the application of harmonic function to robotics provide a strong method to avoid the existence of obstacle, external forces, and environmental doubt by controlling a manipulator to achieve the aim. So we conclude that the use of the harmonic function as described here allow the control to proceed at the same time as the incremental update likely to result in true reactive planning. So next slide. So our group also had done a discussion uh, on the application of harmonic function in hydrodynamic application, which is provide a simple analytical relationship between an application of the classical continuity theorem for ordinary differential equation, and on the other hand, it is means that that equation that involved is between Bernoulli law and harmonic function. So our theorem is applicable, and we conclude that delta pi and xi is analytic function of gamma equal to 0. So this outcome is the result formed by setting formally t is equal to 0, as I mentioned earlier, which is bound is obtained from the elevation of the free surface for Bernoulli law. So I think that's all from us. Thank you so much.